Assalamualaikum warahmatullahi wabarakatuh. Asyhadu an la ilaha illallah wahdahu la syarika lahu wa asyhadu anna Muhammadan abduhu wa rasuluh. Amma ba'du, fa'udzu billahi minasyaitonir rajim. First of all, I'd like to thank the organizer and that to Dr. Chairul who asked me to present for this second symposium, and Dr. Zia Shashab asked me to pick up the topic on Quran, Salam, Higgs boson particle, which I humbled by that invitation, especially. Well, first of all, I have not met Dr. Abdul Salam myself. I mean, most of the audience here met Dr. Abdul Salam in one time or the other. And actually, he went to Indonesia back in 1992 or 93, but I already in the US, so I've never been in contact. But I tried to capture his spirit, exactly how he would like to do his research, and that what he did for his research. Try to capture that. First of all, this is the verse of the Holy Quran that he presented when he received the Nobel Prize in the front of the audience. Let me read this one. Alladhi khalaqa sab'a samawati tibaqa ma tara fi khalqir rahmani min tafawut farji'il basara hal tara min futur ثم ارجع البصر كرتين ينقلب إليك البصر خاسئا وهو حسير. It is Allah who has created seven heavens in harmony. No ingratitude canst thou see in the creation of the gracious God. Then look again, seest thou any flaw? You look again and yet again, thy sight will only return unto thee confused and fatigued. So the word tibaka has been used here. I believe, and probably I'm sure for this one here, that the Salam considered this as the symmetry, which is basically the underlying principle of the universe, and that's how he started his career. Dr. Abdul Salam, again, I have to indicate, he's the first Muslim Nobel laureate in physics. In physics, here I put in parentheses because that Nobel laureate in physics. But he's truly the first Muslim Nobel laureate in history. He received this Nobel Prize in 1979, even though from the perspective of a science, many of discoveries have not been presented to him yet. So he proposed a theory, but the theory itself has not been proven to the detail. Let me put the following way. But let's go over his credential prior to his recommended. The research work that really brings you to his Nobel Prize. It is the unified theory of weak and electromagnetic interaction under the symmetry principle in the algebra called SU2 cross U1. This work been active around this period, 1960 and 1970. So this is the photograph. He's so proud being a Muslim. So he wanted to demonstrate to the world, yes, a Muslim also received Nobel Prize. And then, this is the first time. Let me get back here. Thank you. I just took a copy here. This is the celebrated paper, 1964, by Dr. Salam. The title doesn't mean much for the non-physicists, especially not only but this is only for the what we call the elementary particle physics. It's very small community, very small number compared to the entire scientists or even among physics community. But I'd like to point out to you here, cursor here. So here you may see there is a three letters which corresponds to particles. We'll come to that one in a moment. I'd like to show you something that the first one is called nu. This is the alphabet, in Greek alphabet, that indicates a certain particle. And then the second one is E, stand for electron. And then the third one is mu, stand for muon. So you have a neutrino, basically it stands for neutrino, and then electron and muon. So this is the starting point which leads to the process has. We are talking about elementary particles. When we talk about elementary particles, this is beyond what we end up with elements. In the past, people said about elements that there are 4 elements, but the chemists in the turn of 18th or 19th century says nailed down what the elements are. There are about this periodic table of elements given in this table here. So elements boil to the lowest or the smallest entity, what we call it atom. But it turns out that atom is no longer elementary anymore, so we are introduced with the concept of elementary particles. So if you will start with atom here, this is an atom, just symbol as a circle, consists of a nucleus surrounded by electrons. So there are many electrons running around the nucleus. And these electrons are elementary particles. And then within the nucleus, it turns out it's a collection of what we call as protons and neutrons. And a single proton or neutron consists of now what we call as elementary particles, and they are called quarks. This is about the matter, about the constituents of this universe. And then how do they interact? Now the physicists were able to bring the number down instead of, there are so many forces in the past, but it brought down all the way to 4 forces. This is around 1970s. First is called gravitation or gravity. This is introduced by Newton and has been, I can call it, perfected by Einstein in the turn of the 20th century. And then this third one, the order here is according to the strength of the force. But the third one is the electromagnetism, which is known as electricity and magnetism. And the other two, which are called weak nuclear and strong nuclear forces. So the other forces, gravitation is carried by particle graviton, and weak nuclear force is carried by W plus, W minus, and Z. Boson, and electromagnetism is carried by photon, or we ordinarily see as light. This is the ordinary light. And the strong nuclear force is carried by, they call it gluons. So if I bring all together here, this is the standard model of elementary particles and interactions that physicists already accepted as a fact right now. There's a electron here before, and then muon, and then neutrino, electron, neutrino. However, when Dr. Salam proposed this theory, electroweak interaction, he enforced to come out with the second one. Let me see the cursor here. This new mu need to exist. Same thing before, like the U, D, which is related to quarks that build the protons or neutrons. At that time, S quark had been detected. So history forced to have C or charm quarks. Probably, but when I heard, including when we talked with Mahdi Sabr about this sometime, he said that this is a verse of the Holy Quran given here. I will present it here, and this is the Holy Quran, and the meaning of this verse is, holy is He who created all things in pairs. As well, what earth grows, which is basically the plants, and of themselves, and what they know not. So the second particle term, which detected after his theory, made a very compelling reason for scientific communities, physics community, to accept his theory. as the theory of, okay, I have 2 minutes left now. So his theory is based on what we call gauge symmetry of interaction. Okay, there's a global gauge transformation, local gauge transformation. The global gauge transformation will give a conservation of charge, but the local gauge transformation indicate that force is carried by a carrier or a messenger. In fact, the term messenger has been used to indicate how these electrons and the other electrons interact. This messenger is called photon. Okay, this is another quotation that I picked from the Holy Quran, saying that this is another description of that kind of interaction, that angels are messengers who have 2 wings, 3 wings, and 4 wings. 2, 3, and 4 have been indicated in the carrier of the forces, both in the weak forces and the strong forces, that how they interact through the materials. Okay, I think I stop here because of the time, but there are more items related to the Higgs boson that has been the topic for this time. In the end, this is the contribution of Dr. Salam after that discovery toward unification of forces. And finally, the Higgs boson is discovered only recently, but last year, in CERN in Europe. But all of evidences, including the W boson and Z boson, are discovered much later after he received the Nobel Prize. Thank you.
Jazakumullah, Dr. Bahri Sahib.